Hello, my name is CJ Kaufman, and this is my final presentation of the anti-theft device I built to dissuade package theft with an Arduino. This is the flowchart of how I designed the system to work. Blue boxes represent states, and red diamonds show where the scenarios can split based on input. We start at the green circle and tell the Arduino which pins correspond to the button, the ultrasonic sensor, the IR motion sensor, the buzzer, and the LED screen. Once the power is attached or turned on, we start off in the disarmed state. We stay here unless or until the user presses the hidden button, at which point the counter records the button has been pressed and changes the state to armed. From here, the buzzer and LED are ready to react if the ultrasonic sensor detects something within 3 inches or if the IR sensor detects any nearby motion. It'll be set off by either of these things. I'd like to point out that I did not include a route to continue checking the button here because to disarm the package, you would need to be close enough that the IR sensor would almost certainly pick up on your movement anyway, but it should be noted that the code will still be checking for whether the button is pressed here and will disarm if it is, but stay in the armed state if not. From the armed state, if anyone is detected, the package will enter the alarmed state, setting off the loud buzzer noise and displaying the message alarm triggered on the LED screen. The LED alarm triggered text will go away once the sensors are no longer detecting anything, but the buzzer will continue to make noise until the system is disarmed. This should encourage whoever's inside the house to come get their package before anything else happens. Once the button is pressed, the cycle restarts with the system only leaving the disarmed state if the hidden button is pressed again by the user. These pictures show what the physical setup of the box looks like on the inside. The larger image on the right shows the Arduino and breadboard both attached to the bottom with duct tape and a 9-volt battery in the upper right-hand corner. Poking out on the top panel is the IR motion sensor's white dome, placed to have a good 360 view of any oncoming thieves, and sticking out of the package towards the right side is the ultrasonic sensor, placed on the side where people commonly grab to pick up boxes. This image on the left shows how the LED screen was lifted from the breadboard while maintaining connections. The button is still on the breadboard here, but will be similarly lifted off, hidden just underneath the top flap of the upper left-hand side of the box so that it can be pressed to disarm when the box is closed. This is the wiring diagram. Note that the buzzer, button, and LED are attached to the breadboard for a clearer picture, whereas the real prototype has everything except the buzzer separated with wires. The Arduino's only power source when activated in the package is the battery. This is the initializing of the code where I tell the Arduino where everything is and make values and counters. Code that I used from others is cited in the comments with an access date. I also attempted to increase clarity not just by descriptive comments, but also by separating out which sections of code belong to which sensors or devices. In the setup section, I clarify what needs to be classified as inputs and as outputs. This tells the Arduino where it should receive and give information and commands. I also set up a serial for the ultrasonic sensor and the LCD's grid. Getting into the loop section of the code, this shows mostly the button and ultrasonic instructions. First, I set the LED's cursor, but that comes in more in the next image. The button is programmed to, if pressed, change the counter. So if it was 0, it will change to 1, arming the package, and if it is pressed again, the counter will change back to 0, disarming it. There's a delay here to prevent one push from accidentally counting multiple times. Printing it to serial monitor helped me troubleshoot during testing, and I figured it would be helpful in case I ever wanted to mess with it again. The ultrasonic loop, much of this from the same citation specified earlier, tells the sensor to send out audio for just a moment, wait 2 microseconds, send out another burst for 10, and then listen for when it hears the echo. It then converts the time it waited to an amount of distance and prints it to the serial monitor with a brief delay. This last piece covers the motion sensor, LED, and buzzer. First, we get to the reading from the sensor. If the value is 1, then motion is detected, and the LED will turn on just for good measure. This also helped with testing. Once motion is no longer detected, it prints motion ended to the serial monitor and changes the LED to low. This code is also from the cited site on the initialization slide. This unsigned character line is obsolete. You will see this and lots of commented outlines on my code in my final code that I chose to keep as a good reference while I was working out how to fix things and for if I ever want to go back. It does not impact the code as it currently functions. Next, if the counter is on, meaning the system is armed, the LED will say armed. If either sensor is triggered, the ultrasonic sensing something within 3 inches or the motion sensor reporting a value of 1, the buzzer will sound off and the LED will print alarm triggered. Once the rightful owner comes to press the hidden button and disarm the system, the buzzer turns off and the LED displays disarmed. Demonstrations are as follows. Arming the secret button. Whoa. Christmas is saved, hooray! I just wanted to take a final quick moment to show what was displayed on the LED in these scenarios since the video couldn't pick it up. Before I pressed the button, it was disarmed. I pressed it once to arm the system, and then once either sensor was triggered, the LED displayed this combination armed and alarm trigger text to strike fear into the hearts of Grinches until the owner comes to disarm the system again. Merry Christmas!